If you're just tuning in, my name is Mr. Munir, and I'm your math teacher. Okay, this is a rational exponent. Very good. But what is the next thing? It says understanding rational exponents and radicals. Okay, so radical, right? If I want a radical 2, that's not just like a wild and crazy 2, right? I teach this class 4 times, so sometimes I like reuse a joke. It's like funny the first time when it just comes to mind, but then for me it's stale, even though it's the first time you guys have heard it. It's not just a wild and crazy 2. It's a radical 2. Thank you. Thank you. At least I got a reaction. All right, it's not a wild and crazy 4 either. What would it be? Radical 4 is what? What's another thing? Radical 4, it's the what of 4? Square root of 4. Square root of 4 is 2, yeah? Okay, so we understand what a radical is. Now, if there was a number here, I would usually put a 2 there, right? What if I wanted cube root, like cube root of 8? What would I put right here? A 3. What's the cube root of 8? 2. Why? Because 2 times 2 times 2 is 8, right? That makes sense? Yeah? Okay. Cube root of 8 is 2. All right. Oh, let's pray. Let's pray. Let's pray. Lord, thank you, God. Thank you for reminding me to come to you, God. And we do come to you, Lord, in Jesus' name. And we thank you. We come with open hearts, Lord, knowing that you are the master and you are sovereign and you are the almighty King of kings and Lord of lords. And Lord, so we come to your throne, Lord, in Jesus' name, and we praise you and ask for your blessings, God. I say you bless this class, you bless this time. Fill us with your Holy Spirit and help us to end this day strong. We love you, Lord. In Jesus' name we pray. Amen. Amen. Okay. Okay. So we understand rational exponents, we understand radicals. Let's go now. Let's move forward. Let's begin our lesson. So if we open our books and we take a look, we see here, starting with powers of 3. Well, it's not the easiest thing to see. A little better. Starting with powers of 3, we have 3 to the third equals what? 27, good. 3 squared equals 9. 3 to the first equals 3. So each time my power is going down by 1. It's decreasing. The exponent is decreasing by 1. And these numbers here is what? To get from 27 to 9, I have to do what? Divide by 3. From 9 to 3, I have to? There you go. So dividing a power of 3 by 3 is equivalent to decreasing the exponent by 1. Does that make sense? So this is kind of a hint at what we're going to get to in a second. So let's take a look here now at step C. 3 to the third is 27. 3 squared is 9. Each time we're dividing by 3. 3 to the first, decreasing the exponent by 1. Dividing by 3 is 3. We decrease the exponent by 1 again, we get 3 to the 0. So if each time we're decreasing the exponent by 1, we're dividing by 3, we should divide by 3. So 3 divided by 3 is 1. Very good. And in fact, any number x to the 0 power is equal to 1, except for 0. That's the only one. 0 to the 0 is non-existent. Okay? But any real number other than 0 to the 0th power is 1. So what's 8 billion to the 0th power? What's negative 87 to the 0th power? 1. Okay? All right. So there you go. So we have 1. But if we keep going, we decrease the exponent by 1 again. 3 to the 0. Decrease it by 1, we get 3 to the negative 1. Each time we're dividing by 3, so we should divide by 3. What's 1 divided by 3? 1/3. Very good. And if we keep going with this, decrease by 1 again, we get to negative 2 in our exponent. 1/3 divided by 3 is what? 1/9. Very good. And just to kind of show you, if I do 1/3 divided by 3, that's the same thing as 1/3 divided by 3 over 1, right? Yeah? And 1/3, when I'm dividing by a fraction, is the same as multiplying by the reciprocal. So it's 1/3 times 1/3. Multiplying fractions, 1 times 1, top times top is 1, bottom times bottom is 9, right? So that's a very kind of detailed way of saying that 1/3 is divided by 3 is equal to 1/9. Okay, but we understand this. When dividing fractions, we multiply by the reciprocal. Okay? All right. Interesting. Now let's take a look at this in another way. So you can write this in your margins, or if you have scrap paper, if you'd like. You've actually kind of got most of the information already there, so you can kind of just pay attention. 3 to the third, what did we say that was? 27. 3 squared is what? 9. 3 to the first is 3. 3 to the 0th power is 1. Any number to the 0th power other than 0 is 1. 3 to the negative 1 is 1/3. Very good. 3 to the negative 2 is 1/9. Good. And 3 to the negative 3, if we continued, would be 1 over 27. Very good. Well, let's take a look. Do you guys see any symmetry here? 27, 9, 3. 27, 9, 3. 1 in the middle. Let's take a look. 3 to the negative 1 is 1 over 3. Well, 3 we know is the same thing as 3 to the first power. So 3 to the negative 1 is equal to 1 over 3 to the 1. 3 to the negative 2 is 1/9. We know 9 is 3 squared, so 3 to the negative 2 is the same as 1 over 3 squared. 3 to the negative 2 is the same as 1 over 3 squared. See? 3 to the negative 3 is 1 over 27. We know that 27 is 3 to the third, so 3 to the negative 3 is the same as 1 over 3 to the 3. 3 to the negative 3, 1 over 3 to the third. 3 to the negative 1 is 1 over 3 to the 1. 3 to the negative 2 is 1 over 3 to the 2. 3 to the negative 3 is 1 over 3 to the 3. You see this? See the pattern? X to the negative a, any number to a negative exponent, is the same thing as 1 over x to the a. Same thing as 1 over that number. See, that's our rule here with negative exponents. Okay, got that? Let's see if we really got that. Let's go ahead and do 4 to the negative 3, 3 to the negative 4, and 5 to the negative 2. Go ahead and do those on your own. Just for you guys as a reminder, my helps classes are on Tuesday in the room, not this room, but room 1, 2, 3 over in this room. Okay. I'm always there around 3:15. Get there from 3:15 and we go for as long as necessary. Anyone come to my helps classes yet? A few people, right? Helpful, Matthew? Pretty good because generally speaking we can work on the same material that we've been working on, but we can go in more in depth. All right, so 4 to the negative 3 is the same thing as 1 over 4 to the third. 4 to the third is 4, 16, 64, 1 over 64. 3 to the negative 4 is the same thing as 1 over 3 to the fourth. 3 to the fourth is 3, 9, 27, 81, so 1 over 81. 5 to the negative 2 is the same as 1 over 5 squared. 5 squared is 25. See that? Pretty good? Okay. Good. Good. Okay, now, I need to, before we move one step forward in this lesson, I need to make sure you guys understand some stuff that you've probably seen, you've definitely seen before, but we got to make sure that you understand it. So let's go over something. Once again, you can kind of put this in your margin somewhere, or if you have scrap paper, that might be good. So the first thing is 2/3 squared. Okay. Well, one way we can think about this is very simple, is just 2/3 times 2/3, right? That's what squared means. You multiply it by itself. And we do top times top. 2 times 2 is 4. Over bottom times bottom. 3 times 3 is 9. Okay, but there is another way. Okay, and this other way is what I'm interested in. Does anyone know what I do with this exponent when I've got a fraction? Yes, sir.
You bring it inside to the top and bottom.
Very good. I apply it to the top and the bottom. So it becomes 2 squared over 3 squared. 2 squared is 4. 3 squared is 9. I wind up with the exact same answer, you see? Any questions about that? No? Okay. Let's go ahead and do, I'll leave that up. Let's do 3/4 to the 3rd power. And for the record, guys, on the tests and quizzes on this material, really most of the stuff, except for there is time in this class where we do need calculators, but most of this class, including this section, you're not going to use calculators. So I want us to make sure that things like 2 squared and 3 to the 3rd, 4 to the 3rd, and we're not just relying on calculators to do this. So while you're doing your homework, try not to use calculators. Okay, it's fine if you want to use it to check your work. Okay, so what do we do with the 3? Bring it in to the top and the bottom, right? So it's 3 to the 3rd over 4 to the 3rd, right? 3 cubed is 27. 4 cubed is
64.
Bam. Simple as that. See? Good job, class. All right. Any questions on that? Okay, so I've taught you that so I could get you to this. 2/5 to the negative 2.
Is this an example, or is this just like...
This is just something I'm showing you guys so you're clear on it.
Okay.
2/5 to the negative 2. All right, remember, if I have x to the negative 2, what would that be? That would be 1 over x to the 2, right? Well, in this case, x is 2/5. So this is equivalent to 1 over 2/5 to the 2nd power. You see that? Does that make sense? Okay. Well, what do I do there? I take that 2. I bring it in, right? So 2 squared is 4 over 5 squared is 25, right? You guys following this?
Yeah.
Does that make sense? Okay. So I just brought it to the bottom, then applying that exponent in. Now the only thing left to do is I've got a fraction. Yep, that's a 4.
Thank you.
I've got a fraction within a fraction, so I have to turn it into 1 divided by 4 over 25. And when I'm dividing fractions, I multiply by the reciprocal. So it becomes 1 times 25 over 4, or 25 over 4. Does that make sense? Okay. I'm going to give you one to do on your own now. That's very similar to this. Okay. And like I said, guys, this is just stuff that I'm showing you because it's important that you're able to work with fractions and exponents. It's important that when you see a fraction, you don't just go into mind freak out mode, right? It's like, fraction, no! Like Arnold Schwarzenegger comes out with a grenade launcher and he's like, get down! And it blows up the fraction or something. Anyhow. It was, I know. So let's go ahead and do one on our own. 4/3 to the negative 3. Go ahead and do that one on your own, please. Give you 20 more seconds. Okay. 4/3 to the negative 3. First thing I do is I bring it to the bottom. 1 over 4/3 to the third power. I then take that exponent. I apply it to the numerator and the denominator. I get 1 over 4 to the third power over 3 to the third power equals 1 over 4 to the third power is what? 4, 16, 64 over 3 to the third power, 3, 9, 27. This is equivalent to 1 divided by 64 over 27, which is equal to 1 multiplied by 27 over 64, which equals 27 over 64. Does that make sense?
Yeah.
Yes, sir.
Why can't you just disregard the 1 and put the fraction?
You can. Honestly, that's what, if your mind can look at that and see that and just do that, awesome. I used to teach it that way, but then people would be like, wait, what? Why do I flip? And then sometimes if you got a fraction, it can be confusing, so I just started teaching it this way. But if your mind does that, if your mind just sees like, wait, 1 divided by this fraction, just forget this whole step, just flip the fraction. Awesome, just do that. But this way I think is more comprehensive. Okay. All right, any questions on this? You guys got that? Okay, feel pretty good about that?
Yeah.
All right, okay. All right. Does anyone need that up for a second more? No? Okay. All right, so almost there, guys. We got this. We got this. All right. Now, the next part of this lesson, your book kind of teaches it in an interesting way. I'm going to skip all that jazz and just show it to you directly. How about that? Okay, square root of 4, there should be a 2 there. Square root of 4 is what? 2, right? Cube root of 8, we put a 3 there. Cube root of 8 is what? 2. Well, guys, there's another way of writing the square root. Instead of writing it like this, we can write 4 to the 1/2. That is simply another way of writing the square root of 4. This reads as 4 to the 1/2 or the square root of 4. It's the same thing. So 4 to the 1/2 is what, class? 2. Same thing as the square root of 4. If I want to do 8, the cube root of 8, it wouldn't be the 1/2, it would be the 1/3. So the cube root of 8 is 2. You see? These statements are all equivalent. They're saying the exact same thing. You see? Okay? Does that make sense to you guys? Yeah? Okay. So it's just another way of writing cube root, square root. It's just that fraction, okay? 1 on the top and whatever the root is on the bottom. Got it? Yep. Mm-hmm. Okay. Thank you. So go ahead now. You have the power to do number 3 and 4 on the top of page 99. Number 3 and 4 on the top of page 99. Okay. Give you a little bit more time here. Let's go ahead. First one I think is pretty simple, right? 8 to the 1/3, cube root of 8, we just did that. What's that? 2, right? I could rewrite it as cube root of 8, but it is exactly the same thing. 2. 16 to the 1/2, I could rewrite that as 16, square root of 16, plus cube root of 27, right? I could rewrite it this way, but it's completely unnecessary because both of these expressions are the exact same. So 16 to the 1/2, or square root of 16, is 4, plus 27 to the 1/3, or cube root of 27, is 3. 4 plus 3 is 7. Good. So this whole thing is 2. This whole thing is 7. You guys got that? Yeah. Okay, cool. Nice. Nice. Almost there. Good job, class. All right. Now. Oh, it's about to get fun.
Fun stuff, guys.
Yeah. Get your popcorn out, guys. Get your popcorn. Okay, just a brief aside. I went to the movies the other day. I saw Leap. You want to see Leap? I doubt it. It's this French guy, little boy. It's a cartoon. It's one of those computer animation movies. Little boy and little girl, and they escape from an orphanage. Anyway, it's like heartwarming. Anyhow, it was during the hurricane, and we didn't have power, so we're like, let's go to the movies. It was fun. So anyhow, I ordered like a small popcorn, right? And they bring me out like a popcorn that's like this big. Just like, I'm like, man, I remember small popcorns back in the day. It was like a little popcorn. You just like have a little bit of popcorn. No, it was like a lot of popcorn. I don't know about you guys, but that's just too much popcorn for me.
Wait, how much did it cost?
I don't know, man. It was like $5.
Yeah,
I'm just like, I just want like a $2 popcorn. Like, just give me a couple of kernels, put them in some butter. I don't know. Anyhow, I was surprised by it. I'm sharing my experience, my popcorn experience with you guys. I hope that brightened up your day a little bit. Okay. So, anyhow, Leap was nice. He built pigeon wings. That's why it's called Leap, because he jumped with the wings. I kind of gave away the movie. Sorry. Anyhow, okay. So, okay, let's get to the fun stuff. All right. Okay. If I say to you, right, I'm going to challenge you guys. Your minds better be open and lights on right now because I'm going to say to you 8 to the 2/3 power what? 8 to the 2/3? Wait, I could do 8 to the 1/3. I could do 8 to the 2 squared, but 8 to the 2/3? This is crazy. What do we do? Yeah?
Do you turn it into a 6 and 3?
No, that's an idea though. Yeah? Kind of, yeah. Mr. Bolton?
The numerator is the exponent.
Numerator is part of the exponent, yeah, that's one thing. Okay, yes. Praise God. You guys are all hinting at something that is a way of doing it. I'm gonna do it a little bit different. I'm just gonna show you the way that I think is best because it's just the way I think is best, and you guys can just, join me in this math party, okay? All right, math party time. Woohoo! Get out the popcorn, like I said, small bags. All right, shh. Look, in order to do this, I have to understand something first, okay? Okay. Let's backtrack a second. I meant to do this first. I guess I got caught up. 2 squared to the 3rd power, right? There are 2 ways I can do this. Pay attention. Just watch and pay attention, okay? You don't have to write this down. You can if you want. 2 squared to the 3rd power. Okay, there are 2 ways I can do this. First off, I can do 2 squared. What's 2 squared? 4. And then I can raise that to the 3rd power. 4, 16, 64. And so my answer is 64. Got it? But there's another way to do it. What do I do when I have an exponent raised to another exponent? What do I do with them? Do I add them? I multiply them. So this becomes 2 to the 6th power. 2 to the 6th power. 2, 4, 8, 16, 32, 64. Same exact answer. You guys see this? You see? Okay. You understand? Okay. That's a rule of exponents. If I have x to the a and I raise that to the b power, that's the same as x to the a times b. You don't have to write that down, but that is a rule with exponents. Multiplying exponents. Shh, we're good. Everything's good. Okay, we have 22 minutes. 22 minutes. Shh. All right. X to the a to the b power. Okay, so here we go. We multiply exponents. So let's go back here. 8 to the 2/3. Well, wait a second. What if I had 8 to the 1/3 and I raised that to the 2nd power? I would end up with 8 to the 1/3 times 2, or times 2 over 1, right? Which would be 8 to the 2/3. But wait a second, I can do both of these steps, so let's do that. Instead of doing 8 to the 2/3, I'm going to break that up into an equivalent statement. Okay, instead of 8 to the 2/3, I will turn that into 8 to the 1/3, put that in parentheses, and then square it. You see? You see? 8 to the 1/3 I can do. What is that? 2. Square that. 2 squared is? Bam. You see? Okay. You guys understand that? You break it up. You break it up. You split up the numerator and the denominator, okay? Does that make sense? Let's go ahead and do 4 to the 3/2. Go ahead and do that now. Do that one on your own. 4 to the 3/2. Denominator goes on the inside, numerator goes on the outside. Okay, let's split it up. On the inside, it would be 1 over 2. Outside, it would be 3. 4 to the 1/2 is same thing as square root. Square root of 4 is 2. 4 to the 1/2 is 2. 3. 2 to the third is 8. Bam. Got my answer. You see that? It's cool. Okay, guys. What is this? What is that? What is that? Is that an exponent? What? What kind of exponent?
Rational.
Rational. So what is this? It's a rational exponent. Guys, we understand rational exponents. Good job. Okay, here we go. All right, go ahead. Do number 5 and 6 on the top of page 100 now. Number 5 and 6. Another 30 seconds. Okay. All right. 32 to the 3/5. We break that up by putting the denominator in first, which is 1/5, to the third power on the outside. 32 to 1/5. What's a good guess for that?
2.
2, right? Let's try it. 2, 4, 8, 16, 32. Like I said, you can't use calculators, so the numbers can't be too hard, right? So this is just 2. 5th root of 32 is 2. Cube that. 2 cubed is 8. So this answer is 8. 4 to the 5/2. Okay. Denominator on the inside is 1/2. 4 to the 1/2. 5 on the outside. Minus 4 to the denominator on the inside. 1/2. 3 on the outside. 4 to the 1/2 is 2. Square root of 2. 2 to the 5th minus, again, square root of 2 to the third. 2 to the 5th power, 2, 4, 8, 16, 32. Minus 2 to the third, 2, 4, 8. 32 minus 8 is 24. And we're done. Make sense? Any questions on this? Yes, no? Okay, almost there. Almost there. Almost there. One more step. One more step. We've done negative exponents. We've done rational exponents. What do you think the next step is?
Irrational.
That would be intense. We've done positive rational exponents. What about negative rational exponents? Let's take a look. All right. So we have, let's do 8. We've done to the 2/3. What about to the negative 2/3? right? Well, when I have a negative power, what do? I do 1 over 8 to the 2/3. Simple as that, right? Does that make sense? Okay, 1 over, now I split it up. 8 to the denominator in the inside, 1/3. Numerator on the outside. Okay, I get 1 over 8 to the 1/3. What's the cube root of 8? 2, so that's just 2 squared equals 1 over 4. Cool? Yeah? All right. One more, and then you are free to do your homework. 4 to the negative 3/2. Do that one on your own.
If you have a 0, that's the exponent.
Anything to the 0 is...
Okay.
Anything to the 0 is 1 except for 0. 0 to the 0 does not exist. Good question. Okay, about 20 more seconds. All right. First thing, I do 1 over 4 to the 3/2. Next step, split it up. 4 to the denominator on the inside, 1/2. 3 on the outside equals 1 over 4 to the 1/2 is the same thing as square root of 4, which is 2. 2 to the third is 2, 4, 8. 1 over 8. Got it? Good. Okay. Now, homework. What is your homework? Your homework starts on page 101. It is numbers 1 through 26. Okay? It's more problems than usual. It's because I need you guys to do practice on this. I need you to really practice to the point that you got it. You're just golden. It's good. It's easy. Okay? So 1 through 26. With the notes that you've gotten in the lesson, you're good. Nice doggy. Okay. Okay, so any questions before I release you? All right. 1 through 26. Okay. All right. That's it then. Go ahead and get started now. You guys have 12 minutes. Until the end of the day, you might as well get started. Thank you for your attention.